Today we're going to talk about molar conversions, which also include molar mass as well as the conversions, and then also percent composition. So this is your notes. First thing up is molar mass. It's all of just basically adding up all the masses of all of the elements on there, and in order to do that you have to be looking at your lovely periodic table. You can't do that without that. Okay, molar mass, the average from all the periodic tables. Here is CO2. We have one atom of carbon from the periodic table. It's 12.01 times 1, same thing there. Oxygen, 2 of them, multiply 16 by 2, add those two numbers up, 44.01. So now we're going to use that number. Okay, always start with what information is given to you in the problem. Sorry for that line, we'll get rid of that here. I have to kind of zoom in so I can write better. Alright, and we're going to start with what I know. So I know that I have 4.0 moles, okay, and I want to get rid of that mole, and so what I'm going to do, if I can get this stylus to work here, we're going to divide by 1 mole, always going to be 1 mole, and we want to know the mass, and that was that number from earlier, which is 44.01 grams. Okay, go ahead and do that math with two significant figures. When you're doing your significant figures, you need to look at the starting value, that 4.0, and you also need to look at your molar mass, whichever one's smaller. This one's 4.0's got 2, 44.01 has got 4, so 2 is the smallest one, and then our final answer is going to be 180 grams. And there we go for that answer. Okay. Next one, molar mass is equal to 6.02 molecules. So the 6.02 times 10 to the 23rd, that number is used for molecules and for atoms. So anytime you have either one of those words, you're using that large number. Okay. Continuing on here, okay, how many molecules are in that 4.0 moles? So we're going to start off with what I'm given again, which happens to be 4.0 moles, and we need to know atoms, or not atoms, molecules. Okay, so again we're going to divide by our 1 mole, so that moles goes goodbye, and then that number, that Avogadro's number, is 6.02 times 10 to the 23rd, and that is molecules. Go ahead and do that math. Okay, here's how I would enter it into the calculator. Just do 4.0 times the 6.02 times 10 to the 23rd, and we're going to end up with significant figures. Again, look at what you've got there for your starting number, and then also your 6.02. So we've got 2 sig figs, 3 sig figs, smallest one is 2. So our final answer is not in the highlighter, is 2.4 times 10 to the 24th molecules. And there's our final answer. Okay. Next part here, what is the molar mass of barium? Sorry for that red line. First thing that you need to do though is, in order to figure this out, is you need to know the actual formula name for this, or the formula for it. And this is what we just talked about. Barium is a +2 charge, hydroxide is a -1, and so we're going to get BaOH in parentheses with a 2 on it. Okay, so now I go to my periodic table. Okay, barium is 137.33 grams per mole, and we just multiply by 1. Okay, because there's only one of them. The next one, oxygen, 16.00 grams per mole, and there's 2 of them, so we'll multiply by 2. And then the last one is oxygen, 1.01 grams per mole, also multiply that by 2. Go ahead and add those all up, and we're going to get, for a total then, 171.35 grams per mole. Okay, When you are doing molar masses, okay, always go out to 2 decimal numbers. And I'm going to write this here, 2 decimals. If I can write it on here. Sorry about that. Let's hit that back here. I want you to write that when we're doing our, you know what it is, 2 decimals, okay? Write that on there. Next one. What is the molar mass of calcium phosphate? Again, do your formula first. Calcium is a +2. Phosphate is a -3. We're going to be looking at Ca3, PO4, 2 as our final formula. Okay, so now let's go over here and actually figure it out. Calcium from the periodic table is 40.08 grams per mole, and there's 3 of them, so we'll multiply by 3. Next one, phosphorus is 30.97 grams per mole. Again, I'm getting those numbers from the periodic table, and we happen to have 2 of those. And then the last one is oxygen, 16.00 grams per mole. And when I look at this formula, I want to multiply the 2 and the 4 together. So we'll multiply that by 8. And then what I'm going to do is simply figure that all out, and I'm going to add those ones up. Okay? And when I do that, I'm going to get 310.18 grams per mole as my final answer. All right, percent composition, okay, which is simply by mass, what's the percentage, okay? How much copper or how much calcium or whatever element is in that compound that you're dealing with. Formula, mass of the element divided by the mass of the compound times 100%. Again, this is all stuff you've already done, so I'm doing this real quick. So first thing we have to do is figure out this lovely molar mass of PbCl2. Okay, so that's just what I just went through, and that's going to be 278.10 grams per mole. Again, I'm going out to 2 decimal places when I do my molar masses. Okay, and so here we go. Percent of lead in the compound, okay, in our PbCl2, okay, there's only 1 lead, so I'm not going to multiply anything to it. I'm just going to look on the periodic table, and in order to do that, sorry about that line, what we're going to have, lead on the periodic table is 207.20 grams per mole, and then I divide by that number that I just figured out, my 278.10 grams per mole, and then we'll multiply by 100%. And when we do that, we need 5 sig figs total because there's 5 in the top, 5 in the bottom. The 100% doesn't matter, so we're going to be dealing with 74.506% as my final answer for that one. Okay. Now, for the percent of calcium, and I will get rid of these 2 wacky lines here if I can. So we've got in our formula PbCl2, okay, so since there's 2 chlorines, chlorine is 35.45 grams per mole, I'm going to multiply that by 2 and then do the division of the 278.10 grams per mole. Okay, and when I do that, multiply and then divide, 4 sig figs for this one, 25.49%, and there you go. All right, last one here. Okay. The percentage of the percentage composition is unknown, but I know I have these grams of sodium and grams of chlorine. What is the percent composition of each element? First step is to determine the total mass. So I'm simply going to take my 5.75 and my 8.86 grams, and I'm going to add that together, and that's going to be 14.8 14.61 grams. Okay, that's my total. All right, now for sodium, okay, since I don't know how many atoms I have, I can't go to the periodic table and put that number down, but I do know up here at the very top that I have 5.75 grams of sodium, and that's what I'm going to put down here. So I've got not in highlighter, 5.75 grams divided by my total, which is 14.61 grams. And then also, again, we're multiplying by 100%, and we're going to get 39.4% for my sodium. And that's what I've got. Then, for my percent chlorine, do the same thing. Take the number from up above, 8.86 grams, divided by the total, 14.61 grams, again times by 100%, and we're going to get 60.6%, and that is going to do it for today for notes, and then you'll have some worksheet, and we'll also do a lab with percent composition, and that takes care of everything.